a bunch for the invitation to be here, and we will try to get you out of here before it gets too late this afternoon. I want to just talk a little more broadly about bioenergy, and when I use that term, I mean both biofuels. Well, it's not both. There's actually 3 or 4 things you want to consider. And I'm going to talk primarily from a domestic experience, but I think some of these things are evolving in the U.S. at a pace and are coming together that will give us lessons that are applicable in a lot of other cases. So when we use the term bioenergy, it means biofuels, liquid fuels primarily for transportation. It means using biomass for electricity generation, and we're pushing pretty hard on that here in the U.S., and it implies using it for heat. There are also sort of industrial applications that I'll mention, but so there's a range of demands for biomass that I'm going to touch on in a minute, and the confluence of those is something that we really need to watch carefully. So I'm going to talk a lot from the output of a policy dialogue that the Heinz Center and the Pinchot Institute have been running, talking about essentially the development of bioenergy in the nation's forests. It's expanding to include agricultural uses as we go to regional perspectives, but we brought together folks from the forest products industry, the electricity industry, the ethanol industry, a variety of NGOs, a variety of state and federal folks and academics to talk through what are the issues around the sustainability of the energy futures and bioenergy futures that we're pushing towards and building incentive towards at this point. So what we came out with is a mixed message, but a sort of subtle one. It could be a potentially very important source of energy in any of those forms, heat, liquid fuels, or electricity. But it's also one that, as with any natural system, you can manage it sustainably or you cannot manage it sustainably, and we really need to pay attention to that. We won't necessarily get a sustainable system with the set of policy incentives that we've put into place so far. So in the United States, we have an existing forest products industry, a robust industry that uses biomass to generate a lot of its own energy. The numbers are somewhere between 60 and 75% of the energy that's used by the forest products industry is generated from materials that they take out of the woods, and that's the residuals or slash or whatever mill materials. And they use it for their own process heat and to generate electricity, sometimes for their own use and sometimes for sale to the grid. So the existing forest products industry is using renewable energy to produce most of its own energy needs. So that's an important thing to keep in mind as I come into some of the potential conflicts that we're likely to hit. So there's a federal renewable fuels mandate that forces us to generate more of this stuff. From biomass, and pushing on the advanced, the second and third generation cellulosic technologies. And so there's a pretty strong policy mandate and set of incentives that will do that. Renewable electricity or portfolio standards or what have you, I think it's now 33 states. Obviously the national one is under consideration as we speak. And everything has a form of some percentage by some date and with some off-ramps or what have you, but there's in all cases a pretty strong press to bring in renewables for some moderate percentage of states' energy needs. And in some places, there's lots of solar, and in other places there's lots of wind. In some places there's not a lot of either of those, and biomass is on the table as the choice for the major utilities and people who need to respond to this. So it's likely to be a big press in several parts of the country, Southeast, Great Lakes, etc. There are also a growing number of pellet plants that convert biomass into pellets that can be used in automated operations. And a lot of that stuff is being exported to Europe so that they can help meet their renewable energy goals. But that's yet another demand on the nation's forests. And then there's a lot of discussion about the sort of distributed heat processes where you use biomass to produce both thermal energy and electricity. as in Minneapolis-St. Paul district heating applications. There's a lot of universities that are now moving to combined heat and power applications. So there's a lot of folks looking at the nation's biomass and in some cases looking at the same trees and assuming that they're going to be available to them and not to the other folks. And so we're setting up a pretty significant set of competition processes here. The issue that we've sort of started to realize, and Jason kind of touched on this, these are fairly land-intensive processes compared to the things that they replace. So in order to produce electricity, a terawatt hour of electricity, you need between less than 20 square kilometers of land gets disturbed. And these are Nature Conservancy numbers that are just coming out. In order to produce that same number, 1,000 megawatts of, that same terawatt of electricity with biomass, you're talking 300 to 400 square kilometers. So substantial increases in the amount of land that's going to be required to meet our energy needs. And similar kinds of, although biomass is clearly the most land intensive, both solar and wind have a non-trivial footprint. This is some work that was done by the Pinchot Institute. The forest products industry, roughly, and this is the softest number. This number doesn't come out directly, but around 11 million acres of harvested land a year. If we do the renewable fuels mandate and the renewable electricity mandate and making some reasonable assumptions about what percentages of those are going to come from forest products and which are going to come from agricultural products and wind and solar, reasonable estimates are that the renewable fuel standard will add another 2.3 million acres to the mix. So we'll have to harvest more acres. And the renewable electricity process will add 15 million acres more. Now, the questions that arise out of that are those additional acres? Or are those acres that are now not going to be harvested by the forest products industry because someone has essentially bid away their raw material? It either comes from existing lands that are under production for forest products or agriculture, or it comes from land that's going to be converted from some other use right now to that. And those are going to be natural forests or other areas. And there's no free lunch here. Those lands are now producing other ecosystem services. They're supporting biodiversity. I've heard a lot of people in this business talk about putting these plantations on marginal lands. Well, marginal lands are often marginal because they don't grow stuff very well. They're too steep, or the soil's not good, or what have you. And so, as John mentioned, the sort of productivity of things will be quite different. And marginal lands are often what other people call biodiversity habitat. They're the places that are left in this country that aren't used intensively for other purposes. So we're going to face choices where we either take new lands and put them into production, or we squeeze out existing uses. And so that's sort of one of the questions that we need to be focusing on. Another point, and I was interested to see the numbers on ethanol, because I've asked a couple folks this question and couldn't get an easy answer. But if you burn wood or pretty much any fuel, you get about, for electricity alone, and you just put it into a boiler and make electricity, you get about 25% of the, at maximum 25% of the energy back out. So essentially you put 3/4 of the energy up the stack or the cooling tower and you get about 1/4 of it as electricity. If you burn something for heat alone, you get about half or more of the energy back. So you're wasting less in the process. And if you put that into a combined heat and power where you use thermal energy for either heating or for process energy, as the forest products industry does, and you generate electricity with the other half of the cycle, you can get very high efficiency operations. And some of the European applications for small-scale, regional, city-sized heat and power productions are up at over 90% efficiency. And with a resource that is scarce and hard to manage and competed for by many different folks, the notion of thinking carefully about how efficient we we are and what applications we use, and making sure we put them towards the most efficient applications and most direct applications seems to make sense as part of an overall mix. I want to just go through, because there are multiple potential impacts from any of this bioenergy development. And again, done carefully, you minimize these impacts. Done sloppily, you get these in huge amounts. So the easiest one is sort of direct land use changes. You either put it someplace and take, say, existing forests and convert them to plantations or other uses, or you supplant existing agricultural or forest products land, and that demand goes somewhere else. If there's going to be a certain amount of corn consumed in the world, if we put biomass energy crops on some corn land, that's going to get grown somewhere else, often with significant carbon emissions in the process. So the moving land from one category to another, and what the spillover effects of that are pretty significant. Water quality changes and water quantity changes. Growing this stuff and processing it takes water through fertilizer use and direct use in the conversion. Biorefineries, ethanol refineries in particular, are often very water intensive, and so have local impacts on other users and on biodiversity. Biodiversity impacts can come out of the land use changes, come out of the water quality changes, can come out of fragmentation of habitat, can come out of introduction of invasive species that are the plants that are being grown in the dedicated energy crops, and some of the kinds of things that the international certification roundtables are working on are ensuring that when you grow these crops for energy use, there you minimize some of those impacts, not using plants that are highly invasive in nature. And the last that I sort of mentioned earlier is the competition with existing industries. If you're not going to use unused land or biodiversity habitat, you're going to use land that's currently in production for something. And again, when the forest products industry in the U.S. is using a significant amount of biomass in a very efficient manner, they're using, again, in this combined heat and power, or often in the heat alone, sort of in the higher efficiency strategies, bidding that away by subsidizing electricity production or subsidizing ethanol production, and putting it into a use that's less efficient may actually lower your overall efficiency in the system. So thinking about what kind of process you put this through and where we direct the subsidies makes good sense. So I didn't have three big ideas, I had three big questions. Things that you ought to be asking when you deal with biomass and bioenergy, biofuels kinds of production. Where is this going to go? And what lands are going to be used for it, and answer that question in a sophisticated way, not just where is it actually going to go, but what are the secondary effects from that, and what's in the current discussion as indirect land use effects. On those lands, what services are going to be displaced? What are those lands producing now? I've heard of degraded lands, and there may be fewer of those in the United States than there are in other places, but almost everywhere that I look in the U.S. where people think of putting something, there's already a constituency for the services that are coming out of that. I saw a long presentation about solar development in the Mojave Desert yesterday, and deserts are often thought of as the great wastelands and treated that way, but they're important biodiversity areas and recreation areas, and so even places that are that we often think of as not having huge values or not being well valued are going to have services, going to have constituents, and you're going to have to deal with the trade-offs. And last again is, how efficiently is this stuff being used? Are we putting it, given the limited resource that's available, and given the multiple demands that are now coming, at least in the United States, and I suspect in other places, every country's going to have a fuels and an electricity issue to deal with in the future. Thinking about the efficiency of these applications is one way to make sure that we're being as sustainable as possible and using the resource as carefully as possible.